This video is about geometric sequences and how to find the recursive and direct rule for geometric sequences. Hopefully you've already figured this out, but it's still a good idea to watch the video. It'll be a little bit shorter than most of them. Take notes because that will help you later on when I ask you to explain yourself and explain how you got the rule. This video can help you do that. So let's start by looking at an example. So 2, 6, 18, 54, etc. Of course, first we ask, is this sequence geometric? To do that, we look for the pattern between the numbers. And we notice to get from 2 to 6, well, you could do plus 4, but then the next one would be plus 12. So that's not necessarily helping us. But we can look and notice that we can also get from 2 to 6 by multiplying by 3, which of course works from 6 to 18 as well. 6 times 3 is 18, 18 times 3 is 54. So yes, the term value is increased by a factor of 3. In other words, to get the next term, we multiply the previous term by 3. So this is a geometric sequence. But let's look at that. To get the next term, we multiply the previous term by 3. That sounds like a recursive rule, and in fact it is. That is part of a recursive rule written out in words. Can we write it in sequence notation? Sure. A sub n equals a sub n minus 1 times 3. Yay, we're done. Oh, but wait. That could also describe this sequence, 1, 3, 9, 27, because to get the second term, we had to multiply the first term by 3, 1 times 3, to get 3. To get the third term, we had to multiply the second term by 3. 3 times 3 is 9. 9 times 3 is 27. So that recursive rule could be 1, 3, 9, 27. Or it could get us 5, 15, 45, 225. There are an infinite number of sequences that could be described by a sub n equals a sub n minus 1 times 3. So that can't be our recursive rule. But I thought we were multiplying our previous term by 3. In fact, we are. But we need to always say where we are starting. Some of you forgot this with the arithmetic recursive rule. So let's try that again. We have to tell us to start with a sub 1 equals 2, and then we can say a sub n equals a sub n minus 1 times 3. Now we know we're starting at 2, and then to get the next term, we multiply the previous term by 3. To get the second term, we multiply 2 times 3, because 2 is the first term. Okay, so that's the recursive rule. Now let's talk about the direct rule. So, of course, we want to start with a table. We have n, we have a sub n, and then we're always going to show our work because that is where the formula or the rule or the equation comes from. So, the first term is 2, second term 6, third term 18, fourth term 54. That's all given. We know all that information. Great. So, what if we wanted to find the 100th term, though? To find the 100th term, we would need to know the direct rule. The recursive rule won't help us because the recursive rule would tell us to find the 99th term and then multiply that by 3. I don't want to find the 99th term because then we have to find the 98th and the 97th. So the recursive rule really only helps you get the next term. We need a direct rule so we can directly go and find the value of any term, including the 100th term. So how do we do that? Let's look at our work. So we start with 2, and then how did we get to 6? Well, we did 2 times 3 to get 6, so let's write 2 times 3. And then how did we get 18? Well, if we go all the way back to the start to 2, we do 2 times 3 again. So let's write that down. And to get the 54, it would be 2 times 3 times 3 times 3. So we'll write that down. So we know for the 100th term we're going to do 2 times 3 times 3 a bunch of times, but we don't know how many times we're going to multiply by 3. Hopefully you have figured that out already, but let's just look at the pattern anyway. So in the second term we notice we do 2 times 3 and multiply 3 one time. And in the second term we do 2 times 3 times 3. We do it 2 times, so 2 times 3 to the second power. For the fourth term, we had 2 and we multiplied by 3 times, or 2 times 3 to the third power. So for the 100th, there are going to be 99 3's, so it's 2 times 3 to the 99th power. That helps us if we plug in n instead of 100. We know we're going to have 2 times a bunch of 3's, but how many? 1 less than the term number. So 2 times 3 to the power of n minus 1. So there you have it. That's our direct rule. A sub n equals 2 times 3 to the power of n minus 1. Hopefully, even if you already knew how to find the direct rule, this video helped you explain it. Make sure you write down the words that I say. Not all of them necessarily, but enough so that you can explain it yourself in writing or out loud the next time you're asked to explain the direct rule. Goodbye.